Kia ora, thank you. Yes, I work in transport, but this is very much a passion project, so you'll see no affiliation to where I work. It's also kind of how to say, I'm quite new in this journey in understanding cities with FOSS4G, and my hope is that as you see my experiences, it'll excite you to sort of do your own explorations. So yeah, so my sort of fledgling journey in urbanism is often driven by conferences. So I end up knowing of a FOSS4G conference nearby, and I will think about something I want to learn in urbanism and try to do some work and do some exploration and present it. So in FOSS4G 2023, which was also in Auckland, the Oceania chapter, I gave a more introductory talk on how you can understand studies with open source tools and open data. And there's like a little companion web book associated with the talk at that URL. So hopefully when you get the slides or the video later, you'll be able to go to those links. And then similar conference, there was Spatial Data Science Conference 2023, and I used that to kind of compile my explorations of a hilly city. So I live in Te Whanganui-a-Tara, which is Wellington, the capital city of Aotearoa. It's a very hilly city if you don't know about it. And a lot of things of sort of getting around and moving around are often sort of estimated on cities that typically occur in flat landscapes. That's not the case in Wellington. And so, you know, it was using FOSS4G to kind of virtually traverse the city and summarize it that way. So that's the second talk. And then I've also got a little blog that's been a little ignored. And it's eFlunner, which is just, you know, again, using FOSS4G to sort of go to different places around the world, maybe like test new data sources, again, focusing on urban areas. So that's kind of, you know, my learning so far, and I kind of keep wanting to upgrade myself with new tools and techniques. And this one in urban form is my current sort of learning. And yeah, so why am I doing this? When I gave the talk in 2023 at FOSS4G, one of the data sources was actually automatically, in an automated way, capturing street views, because, you know, we get a lot from an image, and, you know, we can learn a lot about urban character just by looking at a picture. And these were all generated with a little piece of R code. You could sort of give the code a location, and we'll go and kind of give you a little snapshot of the particular place. And these are all places that I've either lived in or lived nearby. And I was quite interested in how different they look and what kind of, you know, they have so many nuances and patterns of urban character. And I was really curious about how you can learn more about these patterns. And, you know, and once you learn about them, can you then sort of correlate with improvements to the city, either that you might want to talk about to your local council, or maybe be part of some sort of activist group and sort of like champion changes that way. And sort of more broadly, I was kind of like, okay, well, it'd be nice to, you know, help in my future self, in my future, to make better cities around the world. And there'll be lots of cities that I can't actually travel to, so I'd need a way to understand them. And so this is, again, a reason for exploring cities with data and open techniques. Cool. What does this talk provide? So there is a GitHub repo with code and materials. So the companion sort of website is also rendered. It's from the same GitHub repo, so feel free to go there. It's got a little bit more detail into some of the techniques that we'll be getting introduced to in this talk. But, you know, it is an exploration, and there may be issues or mistakes, or maybe you will have some suggestions, so feel free to raise an issue on the GitHub repo, or if something doesn't work, again, feel free to raise an issue on the GitHub repo, and we'd be most happy to address it. Cool. So urban form, there's lots of nomenclature around it. There's morphology, there's tissue, there's typology. These mean slightly different things depending on, you know, what you're talking about. So I use typically form to describe kind of the structure, and typologies is when you kind of come up with a pattern that pervades more than a single building or a single street. And yeah, so we're kind of interested in learning about urban character through urban form is one of the key determinants of urban character. There's obviously loads of other ones like socio-demographics, points of interest and amenities, because a lot of how neighborhoods look is basically what people do there, why they come to those neighborhoods, why they might live there. But yeah, so urban form is shaped a lot by planning regulations, obviously geography, historical precedents, population growth patterns as well. So sometimes like the way in which a certain area kind of grows because there's been a huge influx of people in there will shape the way urban structure is kind of sprung up. Transport infrastructure is a major one, and we still struggle to sometimes understand the causality there. Cultural norms, in terms of what kind of ways we build, whether we prefer detached houses like we do in New Zealand, or we're sort of more into sort of high density housing, and of course housing policy, which is, determines what ways in which you can build and regulations therein. I really like this little image here. It's generated by an economist here in Tamaki Makaurau, Aaron Schiff. He did this cool thing where he took building polygons and he sort of overlaid them with the aerial imagery of roofs. So you get this lovely thing called a roofline map. So you can see all the beautiful colors of a city, but with the kind of information that you can also get from a figure ground diagram, which is built space versus unbuilt space. And so his little blog post, which is linked at the bottom, he kind of looks at different parts of Auckland, and he sort of describes what you can learn from these figure ground diagrams. So he describes here this particular part of South Auckland called East Tamaki, where you've got these really different boundaries of urban form. So you've got the industrial area, which is sort of, you can see from the large building polygons sort of spaced out. And then you kind of move into a reasonably organic looking residential neighborhood, and then you're out into the sort of semi-rural and rural countryside. So you see this real shift in this just single sort of part of Auckland. And that's the kind of insights that I was like, okay, well, this is qualitative, because you're looking at these images and you're kind of learning individually what makes them tick. And he has a lot of context because he lives here. But what if you didn't, right? Like, how can you kind of learn about urban patterns without necessarily having lived in the city and know a lot about particular areas? So that's what we will kind of learn how to do today. So yeah, so similar sort of veins, we've got 3 suburbs in Auckland here. We've got Greyland, Ponsonby, East Tamaki, which is the one we saw in the previous slide. I mean, they all showcase a type of residential neighborhoods. We can sort of qualitatively say that they look a little bit different. The two on your left are kind of more block-like gridded neighborhoods, and the one on the right is very sort of organic. But can we actually sort of get more insight, right? Like, are they truly different, or are we just seeing these? So the very first thing is obviously, you try to get just the structural geometries. In this case, they're all FOSS4G, so they're all OpenStreetMap derived. So you can look at the building polygons and describe, you see these sort of block structures, these grids, and then you look at the street networks and you can see, Ponsonby and Greyland, they have these lovely sort of straight streets, whilst in East Tamaki you've got this sort of really crazy mess on the eastern side. But what's really interesting is that, we're choosing to look at suburbs because that's something that many of us who live in cities kind of know. Like, a suburb is this kind of, it has a particular feel to it, right? But these are not the same scale. These are vastly different sizes of suburbs, and the typical approach in doing this kind of visual qualitative analysis is you ensure that the scale is the same. So you're actually comparing what's called urban tissue. So you look at the same scale, whether it's 100 meters by 100 meters or slightly bigger, depending on what level you want to understand urban form, and then you diligently go about and you sort of compare them. But once you start looking at different sort of higher order structures, so you're looking maybe at local authorities, or in this case suburbs, that becomes hard because the scale is no longer the same. So how do you deal with this, right? And that's where an approach, which we're going to discuss today, will actually help us look at comparing different areas no matter what size of comparison you're looking at. So that whole area is morphometrics. It is the metrics of morphology. So we see here the street networks of those 3 suburbs. But what we've done is we've reduced those street segments into bearings, and we've created a histogram. So this is the sort of angle from north, and we've put it in a polar plot, so you can then see like a little compass, what directions are the streets going in. And because it's a histogram, you can see how many of those streets go in that direction. And you pull out some non-trivial insights that you weren't really able to see from the visual, just the pure line strings themselves, right? So you can subtly see that East Tamaki actually has a sort of an axial grid. It's there. It's not as obvious as in Ponsonby or Grey Lynn, because there are streets that are really linear and they go in a particular direction. It's just there's a lot of other smaller streets around them that kind of distract our eyes from seeing that there is this sort of regularity in the street network. Ponsonby, there's, again, a grid. It's not quite sort of 0, 90, 180. It's a little bit offset. And some directions are sort of more, there's more streets in some directions. Grey Lynn is really fascinating. It's got a grid structure, but it doesn't seem to have particular angles that it really favors, right? So it's sort of got quite a few different angles of streets. It's just they happen to be linear, so they trick your eye into thinking that this is a very regular grid structure. So again, you're getting morphometrics to give you more insight that you can't get. And that's the whole key of this talk, is that you can use these morphometrics derived from buildings and streets, and you can use them to classify cities into typologies, because city doesn't have as many unique spaces as sort of little neighborhoods. There's actually a lot of commonality between different areas of a city. Sometimes they're contiguous, as in, common areas are close together, and then you kind of go to a region a little bit further away and it's a different type of typology. But other times you see these typologies kind of occurring even in areas that aren't particularly close together. So this is kind of the punchline visualizations, and we'll go into how we can generate these using some open source tools. But the core concept here is, you can classify cities because these morphometrics are generated, and you can use them to compare different areas of different parts of an urban area. So this is kind of how biological classification works, or taxonomy. You take lots and lots of measurements, in this case of, a bird's wingspan, its tail span, its sort of body length, beak length, width, blah, blah, blah. And you use all of those metrics to see, okay, well, how do these define a particular species? Because they'll all have measurements that are really similar together. And so that's the same idea of a urban typology, is they are parts of the urban area that have very similar morphometrics. And all of this is facilitated by this incredible toolkit called MompI. It is a Python-based toolkit. It contains an exhaustive set of morphometrics. It also has classification algorithms, or in this case, it links to sort of classifiers it uses from other Python packages. It also has certain kinds of street network analysis, so sort of finding contiguous parts of the street network through a particular algorithm called coins. So even though streets change names, they might fundamentally still be a sort of a contiguous street segment, and you can do analyses on that. It has this really new feature called Streetscape, which is looking at urban form, but from the eyes of a pedestrian moving through, so what's actually relevant as a pedestrian. So it's a really incredible and very cool resource. They have lots of guides and tutorials. And what I'm doing in this talk is actually kind of adapting one of their tutorials to New Zealand urban form and making some nicer visualizations in R. So, cool. So morphometrics are basically dimensional metrics. You take these geometries, in this case polygons, building polygons, and you derive a whole bunch of measurements from them. So, an area measurement is a really obvious one. That's what we see here. You can also derive things like equivalent rectangular index. So you compare the polygon to, a rectangle of a similar dimension, and how different is it from the regular shape of the rectangle, elongation, shared walls, and so on. I should note that the metrics used in this talk and in this analysis are just a small subset of the variety that you get. So anybody interested in sort of doing this again in a city of their choosing, you can actually add a lot more than what I've shared here. So just go to the MompI API reference and feel free to just add as many as you want. So the first set of dimensions will be polygon-derived ones from buildings. The second are from streets, because these are the sort of two fundamental structural units that we can get from sources like OpenStreetMap. So for streets, you'll have dimensions like length, the width of the street, deviations, and also sort of less trivial ones like openness, and also something that kind of estimates the linearity of the street. But what's really cool about MoMPy is its flex beyond just deriving metrics from buildings and streets. It also has this incredible concept, and is actually the main unit for the analysis, and that's a morphological tessellation cell. And this is constructed almost entirely from building polygons. And the idea here is that it kind of represents plot or a parcel. And it's really powerful because buildings and streets, they're really easy to get for most parts of the world. Plot data has got its own definitions, and it's really wrapped up in how pieces of land are sold. So it's less about what is the area around a building, and it's more about how they've chosen to sort of cut it up to sell it off to developers. So when you want to do certain types of plot-based metrics, this sort of unbiased approach is way better. So the tessellation cell is the main unit for analysis. I'm going to speed through, sorry. So these are some metrics from the tessellation cell, including coverage area ratio, which is quite big in urbanism. So how much of the plot does the building occupy? And so we've created these dimensional metrics, and the core of MoMPy is actually to transform them into what's called a contextual metric. So on your right-hand side, you'll see just each tessellation cell being, it gets a particular metric called a convexity. It's very mosaic-y because, buildings, tessellation cells that are adjacent to each other can be quite different. But that's not very useful in classification because suddenly you'll have really sharp boundaries, but also very relevantly, space is quite highly correlated, so you need to actually look beyond just a particular unit to actually understand patterns of an area. So they have something called contextual metrics that abstracts the real world space into the spatial graph, and it summarizes a given tessellation cell with the summary of its neighbors. You can look at the sort of first nearest neighbor, you can look at the third nearest neighbor, which is like 3 cells beyond, and it creates a much smoother pattern that's far more helpful in sort of figuring out these urban typologies. Cool, so let's look at some results. Wellington, it's a compact little city. So if anybody is familiar with Wellington, it's not big, it's very hilly, but it has this central core that's quite flat, and that's where the CBD is, and MoMPy very nicely picks that up because the urban form of those areas is very different. So the magenta patch in the middle is where the CBD is, and the sort of olive green areas are actually where the sort of city curves in and around very big hills, well, 300-meter hills, but it goes all the way from sea level, so it feels really high. Curves around the hills, and people have sort of built houses along there. The really cool typology is the bright green one, and these are areas of sort of residential, sometimes sometimes industrial, but they're also built along certain flat patches of the city. So they kind of they're very different to the hilly suburbia of the city. And this is quite cool because there's lots of them around the city. So even a hilly suburb will have a flat patch in the middle because that's where they sort of started building, and then they realized they ran out of space, so they had to build into the hills. But what's cool is the urban growth opportunities that you could potentially see here, right? Like, because they're all similar. You can think of connecting, fast transport corridors through these parts of the city because, they're sort of flatter. You can sort of move more vehicles or move more people in a single vehicle, which would be the best thing. And you can see a lot of other options for maybe alternative modes like active travel. So Auckland, much more complex. It's a way bigger city than Wellington, who'd have thought? So this is just classifying the urban extent of Auckland. There's a lot more to Auckland than this. But you've suddenly got from sort of 4 clusters that describe Wellington to 15 that describe Auckland. And this is a case where you probably want to include more morphometrics in the analysis and get a lot more, drill down into a bit more nuance. But yeah, let's look at some things. So this is the grid layout that we saw in Ponsonby and Greyland way at the beginning of the slide. It's not really a popular typology in Auckland. There's not a lot of areas with grid layout. Now, I'm not familiar with this city, so maybe some of the native Aucklanders can confirm or deny this, but it seems like there's only a few patches where there is this lovely sort of block structure in terms of urban form. What that what it does have is a lot more areas that are similar to East Tamaki, and I didn't know this. So East Tamaki has that sort of more organic pattern in its residential urban form, and that's kind of on your left-hand side, and there's a lot more places, especially in sort of southeast Auckland, that have a very similar urban form, whilst the sort of grid structure seems pretty constrained, more dominant in the central city, and a few patches perhaps outside of it. Yeah, so that's it. I think I've sort of raced through. Thank you for your time. Sort of links again to sort of follow on, and again, ask any questions, and I'm happy to take any questions now.
Thanks for coming on. Just a small question about the bearings of the streets, because I mean the street is two ways, so I would expect to see a line of symmetry in there.
Yeah.
So how is it actually measuring?
I think.
Are we seeing that?
Yeah, I think it's just using the raw line string. So in OpenStreetMap, if you have a single street and it goes both directions, but it just has one geometry that essentially represents it. So that's probably why we're seeing this non-equivalence, if that's the question that you're asking. Yeah. So it's just the geometry that we have access to. Yeah.
Hey, thanks. Fantastic talk. Just wondering if you'd had any thoughts about playing around with multi-scale relationships, like the little polygons to the big polygons to bigger ones.
How do you mean big polygons? Like?
Oh, I was just wondering, I really liked the bit about the interrelationships at small scales. Yeah.
What kind of like data were you thinking would be in the other polygons? Anything? Yeah.
Very exploratory question, sorry.
Yeah, no, that's fine. That's kind of leads me into what is the next step beyond morphometrics, and that's actually adding in a whole bunch of other data about the urban area. So you can summarize things about sociodemographics, and you can add that to the algorithm. So in fact, the people who developed MoMPy, they've got a paper, I think it's got spatial signatures in the title. It's in the companion book. It's in one of the references. And they layer loads of data on top of each other to build their classification, because their idea is that you're not just looking at classifying urban typology, but you can actually start to combine form and function to get a signature of a place. So suddenly you're starting to add those extra bits like amenities, points of interest, how it's used. So is this like largely commercial use? Is this like mixed use, and so on? So there's opportunities maybe for those to be represented by other sort of data sets, like maybe in polygons, most likely in raster data. So if that answers your question.
Yep, yeah. Awesome, thank you.
The LINS data is road centre lines ordered in increasing house number, which if it moved into OpenStreetMap or something, that would be the order of the lines. They do that so that you've got a consistent left and right for suburbs.
Right. Cool. Thank you. I think there were some questions here.
Yeah, thank you very much for this awesome talk. I'm interested in sort of urban form and climate. Like you saw, during Cyclone Gabrielle, that a lot of the areas that were worse, more badly affected were sort of newer subdivisions. And I guess the question is, how do you think cities need to adapt their urban form to account for changing climate and sort of future natural hazards?
Don't know, because I don't work in that area. But I think, that's a great point, right? Like back to what Bex was saying earlier as well. Like if you have additional data that describes something, maybe even about the vulnerability of a particular place, that can go into your classification algorithm, and that will be a different purpose. And now you don't necessarily care about space that looks similar, but maybe spaces that have a similar vulnerability to certain kinds of climate events, right? Like flooding or maybe others. And that would be an excellent use case, I think, of this, and something maybe that councils and regional councils can add to their toolkit.
Awesome.
Yeah.
Thank you.
I think there's a question in the front.
I saw a slide where you were showing the road widths. I think OSM doesn't have road widths consistently across all the data. So how did you get those road widths?
Yeah, so those are derived entirely from MoonPy. I don't know off the top of my head how they're calculated, but yeah, I know what you're saying. I feel like maybe they're just using potentially the difference, the space between the polygons as well to potentially estimate the street width. I'm not entirely sure. They'll have to go into the particular function.
All right, thanks.
Thank you, Shiv. Thank you, everyone.